All right, page 56. I'm looking at question 4. Setting ponds for water purification has the following external dimensions. The walls and floor depth is that. Quantify the site clearance and excavation required if 3 of these structures to be built. There are no trees in sight and all soil conditions are normal. Remove topsoil to a depth of 150 millimeters. All right, so what is the question asking us to do? We just need to do excavation, bulk excavation. All right, now let's look at what the structure is or what it looks like. So it says depth of 2.2. So naturally, this is an underground structure. That is our natural ground level. And here's our structure. So there's the ground, and it's below ground, sub level. And they're saying 4.65 width, depth of 2.22. And this way goes something like that. And this way is saying it's something by 3 meters. So we've got a hole in the ground like so. All right, a hole in the ground. And they're asking us to do just site clearance, bulk earthworks. So what will be step 1? What will be step 1? Now let's look at this book. This is SANS 1200. Notice how thick it is. We are not going to go through every single page in this book. However, I'm going to teach you how to use this book. Very valuable book and helps you a lot as a practicing civil engineer. All right. Considering its thickness, its voluminous nature, it covers almost everything that's got to do with civil engineering structures. All right. And it helps you how? It helps you in a way that if your tender document is designed with SANS 1200 as one of its base documents or referencing documents, it helps you because contractors can't deviate from what's in here. You can literally throw the book at it. All right, they can't do their own thing. They stuck with what's in here. Now let's start with a simple example. And within this example, there's a few principles that I'm going to bring in and some methods. One of them, how to use this. All right. Let's look at a page extracted from that book. All right. In your addendums, in your exam, in your test, you'll be given the relevant pages from that book. All right. Basically, to show me that you know how to use it. Now we're starting with C. All right. Site clearance. Okay. Let's look at 8.2. Schedule items, clear and grab. 8.2, clear and grab. The rate shall cover the cost of clearing the surface, removing boulders of site up to 0.15 cubic meters, removing large trees if their girth around the tree, if you measure with a belt or a measuring tape, 2 meters, 3 meters, because when it comes to felling trees, the bigger the tree, the more costly it is. All right. Remember, we're clearing the site. We didn't pour, we didn't dig foundations, nothing. We're just clearing up so we can actually start our work. Right, and it covers removal of various sizes of trees. And sometimes you've got various other items like an old fence or a dilapidated old building. And it's basically a removal of all those things there. Right, so 821, clear and grab. And if you progress from site clearance, where do we go to? We go to earthworks, because naturally, after we clear the site, we need to start digging, right? We've got different types of digging. We've got surface digging, then we've got bulk excavation, which is deep, all right? And also, clear and strip site is also here, square meters. Look, notice the unit. 8.3 1.2. Remove topsoil to a nominal depth of 150 millimeters of stated or other stated depth, stockpile and maintain. Basically, keep it in that particular area. 8321. Bulk excavation. Excavate in all materials or used for embankment or backfill or dispose of as ordered. And notice the unit now has changed to volume. All right, now let's dwell on these three clauses that we've just found. And how do we incorporate that into our calculations of our quantities? So back to this. All right, so according to Salvy's 1200, the first thing we're going to do is clear and ground, site clearance. So let's call it 1 site clearance. You can call it clear and grub. You can call it any of those two. All right. And what we're doing here, we're clearing this area to start work. And what is the area? The area is simply this portion here. All right. Because we didn't start digging. And those dimensions are given by what? 4.65 times 3.0, giving us a total of 13.95 meters square area. So we cleared the site now. That's how much area we got to deal with. After we clear the site, what do you want to start doing? Number 2, excavation. Right? Excavation. Now, if we migrate from site clearance, earthworks, what's the first thing? Remove topsoil. So, 2.1. Remove topsoil. How much of topsoil? 150 millimeters as per SANS 1200. So we know what the area is, times 0.15, and how much topsoil do we have? And we have a value of 2.09 meter cube. Topsoil. I'm stipulating Q. Very soon you're going to do a project, right? The area is going to be large. And because of the large area and that depth, the amount of material generated from topsoil removal is going to be substantial. Because it's going to be substantial, you can't use it. You have to discard it. You have to get rid of it. That does not come cheap. And when we know volume, then we can actually put a price to it. Therefore, when it comes to topsoil removal, even though SANS 1200 speaks of it in square meters, somewhere, I'm actually extracting it in terms of cubic meters. All right, so for now, commit to memory the fact that when we remove topsoil, we're removing a volume. All right, after that, what do we do? 2.2. Remove the topsoil, we actually now start digging. All right, what is our volume there? Firstly, title. We're excavating in all materials. Why are we saying this? Why am I saying that? Because very soon, if you recall estimation, I spoke about something called extra over. This is where extra over comes in. You'll understand this later on. Remember, we're doing a very basic exercise. If we progress to examples 4, 5, and 6 later on, you'll realize I left some things out here deliberately. Because right now I'm just trying to get some principles, the basic first principles of quantities. Right, so excavating all materials and what we're dealing with. Remember, we already removed topsoil. to that value. Are we going to be using this as our excavating depth? No. So what is our effective depth? That is now our effective depth. Okay, so if that's our effective depth, what is the volume of excavation? All right. We know the area times the new depth, and we get a volume of what? New volume. So that, in short, is the new volume or the volume of material for that particular excavation. Now, what else are they asking of us in this question? They're saying remove topsoil, quantify site clearance and excavation. They're just asking site clearance, excavation. So just do that. Let's forget about the thickness and all of those kind of things of the concrete and all that. All right. Now, this brings us to the end of this example in terms of what's being asked. Now we need to tabulate this. So let's tabulate this. What are we tabulating? We're tabulating our bill of quantities. All right? And a bill of quantities in a very specific format. All right? All right, what's the first column? Notice I've done this freehand. You're going to do this exact same thing in your test and your exam. Use a ruler instead. All right, so first one, bill of quantities. Sands 1200, reference. Then let's call this factor. You can call it times. You call it number, whatever you want. You understand what that is in a moment. Then let's call the next one dimensions. And let's call this one product. This we shall call description, although it should be larger. And this we'll call unit. This we'll call quantity. And this is the rate. All right? But we will not be doing rates. Okay? We'll stop here with quantities. All right. After that, we put in our measurement list. All right, basically, what is this question asking of us? All right, we're answering the question in the bill of quantities, and this is all that we're doing for it, the measurement list. So what is in our measurement list? Let's see. 1, site clearance. Oh, clear and cut. What's next? 2, excavation. Notice where I'm getting it from. What's after 2 or in 2? 2.1, topsoil. And what was after that? 2.2. Excavate in all materials. Okay, that's all. that's being asked of us in this question. Now, problem is that carries between 3 to 4 marks in any assessment. All right. Now, notice we've got 1, 2, 3 items. By the time you'll be writing your exam, you will have a page, possibly a page and a half of measurement list. Hence the reason for the number of marks. Okay. So marks attached to the measurement list. At least 5% of you, this happens every semester, are so eager to tabulate your bill of quantities for various reasons, time being one of them. You actually forget about this. All right, don't. Easy marks. Easy marks. All right, now let's tabulate this. 1, site clearance. All right, and under site clearance, what did we do? Let's go to our SANS reference for site clearance. Okay, there we go. 8.2.1 clear and grab. Under that, we've got 8.2.1. That's where I got it from. Site clearance, clear and grab. Right? Factor. What's that? Remember the question said something about settling points. 3 of these structures are to be built. Our calculations do not reflect 3 anyway. Now, the reason why I haven't, because I've observed this over a decade of lecturing documentation. Students will put in the 3 in that calculation. They will come here when they're tabulating, and in their hurry and stress, they will put in 3 there, and then they'll start multiplying. And the factors just mess up everything. To the point where the student knows his work, but he quantifies something else. That is why I said, let's do 1. Thereafter, because there's a column in BOQ, you can't ignore it. You'll have to do something. How many are there? There's 3 of them. The dimension is 4.65 by 3.0. And if we do that multiplication of 13.95, 13.95 times 3, you're getting 41.85. Right, what is the unit? Meter squared. What is the quantity? 41.85. Site clearance quantified, bill of quantities. Let's go to the next one. 2, excavation. 2.1, remove topsoil. What is the clause for removal of topsoil? Which one are we using? Not site clearance, because we're going to excavation. Right. What is the value? Here's one. 8312. 8312. Or alternatively, you can also use the last one. If you remove of topsoil normal depth 150 millimeters, meter cube. So 8210 or 8.2.10. Either one, because they all make reference to 150 mil removal. So any of these 2, good enough. How much is there? 3 of them. And what's this? 13.95 times 0.15. And what are we getting? Topsoil, 2.09 times 3 of them, 6.27. So this is 13.95 times 0.15. And we're getting 2.09 times 3, 6.23, 2.328. And what is the unit here? Meter cubed, as I've already explained, and our volume there is now 6.28 meter cubed. All right, last one, 2.2, excavating all materials. Materials. And what is the clause for excavating all materials? All right, here we go. Bulk excavation. Excavating all materials, meter cube, 8.3.2 A, not B. All right, because we're doing excavating all materials. This refers to extra over. We're coming to that, right, in another exercise. So what's the clause for this? 8.3.2 A. Has the number of units changed? All right. Now, careful with this. As we progress, you will see different items of a structure have multiple units. So our factors are going to change. There was a student in 1 year, because the example he studied from the start had 3. Every single question, he put 3 there. Because he didn't understand what that meant. I want you to understand, 3 came from the example. It changes. There could be 4. Could be 1. All right, so 3 of them. And what are we doing? Excavating all materials. 13.95 times, what's the depth? 2.0, 2.09, 2.07. And what did we get? 28.88 times 3 is equal to 86.64. Unit is meter cube, 86.64. All right, so there's our calculations. And this is how you tabulate them in full of quantities. Notice SANS 1200, the factors are the number of structures, dimensions. Now, I get this question all the time. Do I put in every single dimension? Sometimes it's not practical to put in every single dimension because there's multiple dimensions. Here, just 2, L times B. All right, you put in what you believe is relevant. There's no marks attached to this. The marks are here and here. All right, and explanation is there in the form of a description. All right. Alternatively, you could do this. Multiply this by 1, and then 3 times that gives you that. Some people will say, you know what, why is this number the same as it? It doesn't have to be. Okay, you could put in what we calculated originally. 13.95. Right? And then you could do the multiplication and subsequently get the answer there. So let's follow on. Up to you. Up to you. All right. But as we progress, you realize why I'm doing this. But you're free to do this. Put in the value of this 1 times that to give you that. So you have a follow on. All right. Either way, I will accept. All right. So that brings me to the end of this particular question. And let's to recap. Quite a bit of principles came in here. All right. We're talking about that from SANS. But before that, how to use SANS 1200. All right, that came from that. All right, sequence of SANS. We're working according to the sequence of that big book. Cyclides, excavation, topsoil, excavation. And then how we tabulate it. From this, I'm saying you need to memorize these columns. You're going to have to draw it. You're going to have to draw this table. Immediately after that, what are we doing? We're doing a measurement list of all the calculations. Carries marks, must be there. And then how we use the clauses for the various calculations and how we tabulate them. All right, now this is where your marks lie. Right there, there, and there. I'm telling you something I tell every year. Some of you may feel that this is a waste of time. They want to jump straight into a bill of quantities, do their calculations, and carry on. I can't stop you from doing that. But here's the problem with doing it. When you make a mess here, if a number is close to my answer, obviously it's wrong. Okay? Do I give you completely zero? Or do I go back to his calculation and see, oh, he made a mistake here. He made a mistake here. That is why it's so much smaller. Therefore, he knows his work. He made a minor mistake. If this carried 4 marks, I'll give him 2. Or depending, I'll give him 1. This is where, in your calculations, I look to give you part marks. But if it's not there for me to see you messed up or made a human error, I can't. And therefore, automatically 0. I just want you to take that into consideration if you want to understand how I mark or how I think at the moment I'm assessing your script. All right? It's a double barrel. I see your calculations, I see the mess up, I know, you know something, I'll give you marks for that. But you know everything, and it's wrong. Nothing, 0. I'm telling you this right at the first question, or the answer to the first question. Something for you to think about. Okay, stop there.